All right, so 9.2 is on adding and subtracting rational expressions. It's really similar to what we did in 9.1, which is 9.1 was multiplying and dividing. So we're going to go a step further. We're going to get common denominators. All right, so number 1, it says add the following fractions. Let's start with the basics. So I have A is 1/3 plus 1/4. So what did you guys do when you learned about fractions? Common denominators. So you'd multiply the first one by 4/4. And you multiply the second one by 3/3 because you wanted your denominators to be a common 12, right? So when you do that, you get 4/12 plus 3/12 equals 7/12. It doesn't reduce at all, so that's your answer. Okay, then you got to a little bit harder. And you had 3/16 plus 1/32 plus 5/64. Now you could multiply all those denominators by what the other ones were, so 32 and 64 for the first one, 16 and 64 for the second, and so on. But what was the easiest thing to do? Make them all 64, right? So the least common denominator is 64. So we're going to change all of them so that they're 64. So that would be 16 times 4 makes 64. So I need 4/4 times the 3/16 plus 2/2 times the 1/32 plus this one's just 1/1, right? So we'll just leave it as 5/64. So I get 12/64 plus 2/64 plus 5/64. You could write them all over 1/64 if you want, one of the 64s. So 12 plus 2 plus 5 is 19, so you get 19/64. Since 19 is prime, I know that that's as reduced as possible. Okay, we cool with numbers? Okay, how about variables? Did I skip one? There it goes here. All right, so it says find the least common multiple for each pair. So let's say that these were 2 of our denominators. So when I say least common multiple, I'm basically talking about if they were denominators, what's the LCD? So the least common denominator. Okay, so if these two things were denominators, let's think about the numbers. If I had 4 and 6 that were denominators, what would be my LCD? Just the 4 and 6. Not 24, not 2, 12, right? You make them as small as possible. So some of you guys are thinking of the greatest common factor, like what goes into both of them. We're talking about multiples, like what would you change them to if they were denominators? All right, so we need 12 for the numbers. Then if I have x squared and x to the 4th as denominators, I would need 2 more x's for the first one, right? I need x to the 4th. And the last one, I have y cubed and y to the 5th. This is where the last class was having trouble. What do you guys think? That's what everybody always guesses. All right, so here's what we got going on. So 4x squared y cubed. And we got another denominator, which is 6x to the 4th, y to the 5th. So you can think of them all expanded, you know. So you have x times x, y times y times y. All right, this one has 2 x's, this one has 4 x's. So that one would need 2 more. This one has 3 y's, this one has 5 y's. So how many more? Y cubed. We would need 3 more. So our common denominator, oh, this one, we'd get 12 too for the numbers. Oh, sorry, I wrote 3, but did I say 2? Or I said both? I was writing the wrong thing. So you need 2 more, right, to make 5. This one just needs a 2 on the denominator. Do you guys see that? So now when you do that, they become 12x to the 4th, y to the 5th. And they're both exactly the same thing. That's what we need for our least common multiple. Does that make more sense when you see it that way? So it's just saying, what are all of these things missing? Okay, next one, so let's factor. So when I factor, I get x minus 3 times x plus 1 for the first one. So the outer and inner combines to be negative 2. On the next one, I need x minus 3 times x plus 2. So that way the outer and inner terms make negative x. All right, so think about what each one has. So if these were denominators, you'd have x minus 3 and x plus 1 on the first one. And you'd have x minus 3 and you'd have x plus 2 on the second one. They both already have the x minus 3. What is the one on the left missing? X plus 2, right? So you'd multiply by x plus 2 over x plus 2. What is the one on the right missing? X minus 1. So that means your least common denominator would be 1 plus. So your least common denominator should be x plus 2 times x minus 3 times x plus 1. Okay, that's the least common multiple. Does that make sense? So you're basically saying, what are you missing? Okay, so let's do this on the adding and subtracting. So in the first two examples, we have the same denominator, x plus 4 on the first one. On part B, we have x squared plus 1 on both of them. Okay, so that means you can just combine into one fraction. So I'm going to have x minus 3 plus x minus 2 all over x plus 4. Okay, so I get x plus x is 2x. Negative 3 minus 2 is negative 5 all over x plus 4. And that's it. Okay, on this next one, I have an x squared plus 1 on both of them. But be careful, you're subtracting. So you're subtracting out this entire second fraction. So what you need to do is think of it in parentheses. So when you subtract, put parentheses there. Because that's telling you that this negative is going to both places. You're subtracting out the entire numerator. Okay, so when I do that, I'm going to have 3x minus 4 minus 6x minus 1. And that's all over the common denominator, x squared plus 1. So I get 3x minus 6x is negative 3x. Negative 4 minus 1 is negative 5. Okay, that's your answer. So negative 3x minus 5 all over x squared plus 1. Okay, so let's do some where they aren't the same denominator. Okay, so one's like this. So we don't want to have to multiply the second fraction by x squared minus 3x minus 4 if that's not the least common multiple we need. So if that's not going to be the least common denominator, I don't want to multiply by a huge one if I don't have to. So when we get things like this, we always factor. So when I factor, I have x plus 4 times x minus 1. That's what x squared plus 3x minus 4 is. Okay, so the only thing that the second one's missing is what? X minus 1, right? So you don't want to multiply by the whole thing if you don't have to. Okay, so when I do that, I have x minus 3 all over x squared plus 3x minus 4, or you can leave it as its factored form. Sometimes it's nice to leave it as its factored form in case something reduces at the end. So we'll leave it. Plus 2x times x minus 1, so I'm going to distribute. So I'm going to get 2x squared minus 2x all over x plus 4 times x minus 1. Now you don't have to write this as two separate. You can combine them into one. That's fine. So I get 2x squared. I have negative 2x plus x, so negative x minus 3 over x plus 4 times x minus 1. And then like I was saying, sometimes it's nice to leave it in its factored form because things will cancel. So we need to factor the numerator to see if it's going to cancel with anything on the bottom. So when I factor the numerator, I need 2x and I need x. That multiplies to be 2x squared. My last terms need to multiply to be negative 3, so I need to have opposite signs. And the outer and inner need to combine to be negative x, so I need negative 3x, and then the outer needs to be plus 2x. See how it works? So 2x minus 3 times x plus 1 all over x plus 4 times x minus 1. So we were hoping things would cancel, but you guys see they don't. So you can write it like that. So that can be your answer, which is fine, and that's actually nice when you graph later to have it in the factored form. Or you can write it in its non-factored form, the FOILed out form, So that would be, we just had 2x squared minus x minus 3 before. And the original denominator was the x squared plus 3x minus 4. Okay, so you can write it like that as well. Okay, so let's try the next one. So I have 2x squared minus 30 all over x squared minus 9, and then minus x plus 5 all over x plus 3. Okay, so this first denominator is x plus 3 times x minus 3. So that means the second one is missing x minus 3. So you need to multiply the second fraction by x minus 3 over x minus 3. So I'm going to have 2x squared minus 30 over x plus 3 times x minus 3 minus x plus 5 times x minus 3 all over x plus 3 times x minus 3. So I just multiplied the second one by x minus 3 over itself. Okay, I'm going to FOIL. So FOIL the second numerator. So when I do that, I get x squared. My outer is negative 3x. My inner is plus 5x, so plus 2x. My last is negative 15. Okay, I'm still going to write this as two separate fractions because there's something I want you to notice. Do you guys see what I'm wanting you guys to see? I heard someone say yes, so what do you want? Yep, distribute your negative. So think of all of this as in parentheses because you were subtracting that second fraction. Because I'm going to subtract out all of these terms. So I'm going to have 2x squared minus 30. Then I'm going to have minus x squared minus 2x and then plus 15. Okay. Keep going. So 2x squared minus x squared is x squared. I have negative 2x. I have negative 30 and then plus 15, so that's minus 15. If you guys are super lazy, I don't care if you just write little like quotation marks, like etc. on your denominator till the very end. Just make sure you don't leave it off completely because you might forget about it at the end. Okay, so then I have x minus 5 times x plus 3. That's how that factors, because they multiply to be negative 15, add to be negative 2. So x plus 3 times x minus 3. So when you do that, the x plus 3's cancel. So your final answer is just x minus 5 over x minus 3. So that's why it's nice to leave the denominator in its factored form, like throughout the problem, because sometimes things cancel. Okay, understand that? All right, is that the end of 9-2?